So the other day we had talked about the difference between flat map and mapMulti and mapReducedConcat as three different ways of trying to get parallelism in a parallel stream. And we mentioned the fact that flat map just unilaterally is limited because it always forces things into this Procrustean bed of single threading, sequential processing. And so the choice is really between stream-concat with map and reduce versus multi-map. And I've written some code that we had looked at a while back, and here's the code. And this is basically code that demonstrates how to use map or map-reduce. And there's a couple of different examples here. For example, here's the one where we have testing the reduce-concat technique. Notice we generate a parallel outer stream, and then we use map followed by reduce stream-concat. That's one way to do things. And then we also had another approach where we used mapMulti. And so I was curious whether, just based on my source code, ChatGPT could figure out which of these approaches would work faster. I wrote a benchmark. I know which one works faster, but I wanted to see if ChatGPT could ferret this out just based on a prompt that I give it. So here's what I said. I said, please read the following Java Streams implementation and assess whether the testReducedConcat method that uses the parallel stream map and reduce stream concat aggregate operations works better or worse, I should have said probably performs better or worse, than the testMapMulti method that uses parallel streams with Java 16's mapMulti intermediate operation. And then I gave it the code. So here's all the code. And what's interesting about this, notice I gave it some pretty good context. I told it that it was Java 16's mapMulti. I gave it the names of the methods that I wanted it to look at. I told it about map versus stream, map-reduce and stream-concat. So I gave it some context so it could go through and ferret this out pretty well. And in fact, it ferrets it out extremely well. And here's what it does. First, it says, I'm going to understand the code. So it's going to take a look at the differences between flat map, reduce with stream-concat, and multi-map. It figured out that's what I was asking it, which I thought was pretty cool. It said, I'm going to focus on the testReducedConcat and testMapMulti methods. It understood those were methods and how to analyze them. And then it starts looking at my code. And this is pretty cool. It says, both methods use generate outer stream to generate a parallel stream of integers, and then use different methods to manipulate and analyze those integers. They both conclude by using all match to check if all operations were performed sequentially or in parallel. That's a pretty good assessment of what that code does. And then it talks about performance metrics. It uses all match to check if the operations were performed sequentially or in parallel, but it doesn't measure time. So it's saying this code here is not timed. I put timing at a higher level in the overall code. This is just a snippet of the code. For a complete performance assessment, time-based metrics would be needed. That is correct. We have those. But let's see what it comes up with without time-based metrics. So it compares these two results. And it compares them in terms of scalability, complexity, and performance, which I think is kind of cool. I didn't ask it to do that, but that's what it did. So it says scalability. testReducedConcat uses map followed by reduce stream concat. That's correct. The reduce stream concat operation generally doesn't scale as well in a parallel context due to the cost associated with stream concatenation. That turns out to be factually correct based on the performance benchmarking that we did. So ChatGPT was able to ferret out that that could be a problem. And then it says testMapMulti uses the mapMulti method, which is designed for better scalability and efficient flat mapping in parallel streams. That is also correct, which is quite interesting. And then it talks about complexity. So now it's no longer looking at just performance issues. It's looking at how complicated is the code to read. And it says the reduce stream concat operation could introduce complexity due to the nesting of streams, especially when debugging or tracing, or especially if you don't know that there's an idiom to do this, which is what I'm showing. testMapMulti, this method is quite straightforward, and the use of mapMulti avoids the complexity of nested streams. That's the whole purpose, or one of the key purposes of mapMulti. So it was able to figure that out too. I thought that was pretty cool. And then it comes up with the final analysis, which I didn't actually ask it to do, but I kind of alluded to it, and it picked up on what I was trying to get it to do. It says, for testReducedConcat, the use of reduce with stream concat may make the code a bit harder. It may be a bit slower in a parallel context due to the reasons stated above, which is correct when we run the benchmarks. And testMapMulti is designed for better performance in parallel streams and would likely be faster and more efficient. So that was very insightful. And then it talks about readability and maintainability. These are also things I didn't really ask it about, but it tells me those things anyway, and I think I probably agree with that. So its conclusion is testMapMulti would likely outperform testReducedConcat, which it does in a parallel context. It's also more scalable, easier to read, and likely faster, and therefore finishes up with its recommendation. If you're going for performance and scalability and also readability and lower complexity, testMapMulti is the one to go with. So I thought that was really, really cool, and it was able to ferret that out. Now here's the other interesting thing, which I know because I did it wrong at first. I have two implementations of this code. One of the implementations of this code uses stream parameterized with integer, and the other implementation of the code uses intStream. And the two implementations are slightly different. And when I first gave this prompt to ChatGPT, I gave it the prompt, but I gave it the intStream code. And so there was, in fact, no method called testReducedConcat. So this is absolutely fascinating. So I gave it this code here. I told it, I want you to assess whether testReducedConcat is better than testMapMulti. But I gave it a piece of code that didn't have testReducedConcat. It had a method called testMap. So the first thing that ChatGPT does is it reads my code, and it says, by the way, sir, you didn't actually give me the testReducedConcat method. It's not there. However, what it does is it figures out what I'm asking it based on the context of my prompt, and it generates the testReducedConcat method for me. So I had not given it testReducedConcat up to this point. It figured out what I was asking. And if you take a look at this code, this is pretty much exactly the code that I have that does this. So it generates the outer stream. It goes ahead and uses the inner stream with map, and then it reduces it, and it uses or else get. So ChatGPT was smart enough to be able to figure out my prompt, what I really was trying to get at, which was this, but I had forgotten to give it the code, and it was able to infer that from the context of my prompt. I think I'll take credit for giving it a good prompt to allow it to do that. And once again, it came up with a conclusion for the same reasons that testMapMulti would perform better and be easier to read than testReducedConcat. So really cool example of how these tools can help you even when you don't help yourself by being able to infer what you're really asking and then phrase the response accordingly, which was really cool. So I thought you might get a kick out of that. I certainly was very impressed with its ability. I also, by the way, tried the same exercise using Claude, which is another LLM. And it was not nearly as good. It decided that testReducedConcat would work better than testMapMulti. And then when I told it it probably was wrong, it of course apologized profusely and said, oh, you're right, I didn't do a very good analysis. And now that you've corrected the error of my ways, I see that you're going to get a better result if you use testMapMulti. So I thought it was interesting how different LLMs have been trained in different ways on how to analyze code. And keep in mind, this is also relatively new versions of Java. So Java 16, not been around nearly as long as Java 8. So mapMulti is not as well known by these LLMs, which is why I gave it the additional context to remind it that this was something from Java 16, because otherwise it would have lacked that context and probably would not have given as fulsome of an answer. Once again, underscoring the very, very crucial point that prompt engineering is crucial. You have to know how to use the right LLM in the right way with the right prompts. And if you neglect to do those things, you will often get substandard results. And if you're not careful, you will start to overgeneralize to think that these tools are useless when in fact you're not using them properly. So that's the take-home point for the day.